Today, we're going to talk about a scientific theory that was so powerful, so convincing, it basically ruled our understanding of the universe for 1,500 years. It was elegant, it was beautiful, it made perfect predictions. There was just one tiny little problem. It was completely, utterly wrong. So how did an idea that was so wrong last for so long? Let's dive in.
And that question right there is really at the heart of our story. I mean, how can a theory that lets you predict eclipses, that seems to explain everything you see in the night sky, how can that be a complete fiction? Well, let's explore what might just be the most successful wrong theory in the history of science.
All right, so to get this, we've got to go back in time, way back, to the ancient city of Alexandria. This is where a brilliant astronomer named Ptolemy cooked up a model of the cosmos that was so compelling it became the undisputed truth for well over a millennium.
What he came up with was the geocentric model, and its appeal, man, it went way beyond just astronomy. It was philosophical. I mean, it put us, humanity, right at the center of everything. It felt right, you know? Plus, it made the heavens seem perfect and orderly. The thinking was that the realm of the divine had to be perfect, so of course, everything up there moved in the most perfect shape imaginable, a circle.
But here's the kicker. This wasn't just some philosophical daydream. Ptolemy's model was a mathematical powerhouse. It actually worked. It could tell you exactly where the planets were going to be. Now, it did have to explain some weird stuff, like why planets sometimes look like they're moving backward in the sky. To solve that, Ptolemy came up with this really clever system of circles rolling along other circles. They're called epicycles. Kind of think of it like a Ferris wheel that's also on a merry-go-round. Yeah, it was complicated, but hey, it fit the data.
So, with this beautiful philosophy and its hardcore math, Ptolemy's model seemed totally unbeatable. To understand how this perfect idea eventually got shattered, we need to look at this fundamental clash that was brewing in ancient Greek thought. It was a clash between two totally different ways of seeing the world.
You can basically think of it as team perfection versus team observation. Team perfection, led by big names like Plato and Aristotle. They started with a belief: the heavens have to be perfect. So their job was to find a model that fit that belief. But team observation, with folks like Thales and Archimedes, they had a different take. Just trust the data, measure stuff first, and then build a theory that explains what you're actually seeing, even if it's messy. For centuries, team perfection was absolutely winning.
So for more than 1,000 years, team perfection was running the show. Ptolemy's model was basically the law of the land. But slowly but surely, a few key players from team observation started to find some cracks in this seemingly perfect universe.
And just look at this timeline. It shows you just how fast a 1,500-year-old idea can completely fall apart. We're talking about a belief that lasted for ages being dismantled in just over a century. It all starts with Copernicus and this simple idea he has in 1514. Then comes Tycho Brahe, who sees something in the sky that proves the heavens aren't unchanging. Then Kepler gets his hands on Tycho's data and rewrites the rules. And finally, Galileo points a telescope up and everything changes.
So first up is Copernicus. And get this, he was a church official, kind of an amateur astronomer. His whole sun-centered model wasn't about some grand new philosophy. Nope, it was just practical. He figured out that if you put the sun in the middle, you could get rid of all of Ptolemy's messy epicycles. And the math just got a whole lot simpler and more elegant.
Okay, next up is Tycho Brahe. And this guy was a character. He was a Danish nobleman who had a prosthetic nose made of brass. He built the world's best astronomical observatory and just spent night after night, year after year, creating the most precise, detailed database of where the planets were that anyone had ever seen. He didn't have a big theory, but he had something way more powerful: cold, hard data.
So this is where it all comes to a head. You've got Tycho's mountain of data, the best data that has ever existed, and it falls into the hands of this young, brilliant mathematician, a guy who is about to use that data to completely destroy the very idea of perfection that he so desperately wanted to prove.
Meet Johannes Kepler. Now, Kepler was a deeply religious guy, and deep down, he was on team perfection. He truly believed the universe was a reflection of God's perfect divine harmony. So when he got hired by Tycho Brahe, he thought, this is it. This data is the key to finally proving the perfect structure of the universe.
But there was a problem. One really stubborn, rebellious planet, Mars. For years, Kepler tried everything to make it fit a perfect circle.
He crunched the numbers again and again, he adjusted the circles, he tweaked the models. But Tycho's super accurate data just wouldn't lie. Mars was off. And the difference was tiny, just 8 arc minutes, a fraction of a degree. But for a mind like Kepler's, it was this massive, infuriating imperfection he just couldn't ignore.
So Kepler was at a crossroads. He had to make a choice. Does he trust his own deeply held belief in divine perfection, or does he trust Tycho's cold, hard data? He chose the data. And in that one moment of incredible intellectual honesty, he made a discovery that changed everything. Planets don't move in circles. They move in ellipses, squash circles. And with that one law, which the data forced him to accept, Kepler shattered a 2,000-year-old belief. The heavens weren't perfect, they were messy.
Okay, so Kepler had the math, but the world needed to see it to believe it. And that's where our final revolutionary, Galileo Galilei, comes onto the stage, armed with this powerful new toy, the telescope.
Galileo didn't invent the telescope, but he was the first person to really point it at the night sky and take notes. And what he saw? Well, it was like a series of knockout blows to the old model. Bam, the moon isn't a perfect sphere. It's got mountains and craters. Bam, the sun isn't a flawless orb. It's got spots. And maybe most shocking of all, bam, Jupiter has its own moons. Not everything in the universe orbits the Earth.
But the final nail in the coffin, the absolute undeniable proof, was Venus. Galileo saw that Venus goes through a full set of phases just like our own moon does. Now, this is just geometrically impossible if Venus and the sun are both orbiting the Earth. It only works if Venus orbits the sun. There was just no arguing with it. It was visual proof. The old model was dead.
So why are we digging up this 400-year-old story about astronomy? Why does it still matter? Because that fundamental conflict at its heart, that tension between a really beautiful idea and the messy reality of data, that's a battle that is still being fought in science right now.
The big takeaway here is really a warning. Just because a theory is elegant, just because it's beautiful and makes accurate predictions, that doesn't automatically mean it's true. Ptolemy's model was an incredible achievement of the human mind, but it was all built on a foundation that just wasn't real. And this brings us right up to today, to some really fascinating debates. Think about something like string theory in physics. It is considered one of the best candidates for a theory of everything. And everyone agrees, the math is just beautiful, it's so elegant. But, a lot like Ptolemy's model, string theory hasn't yet given us a single prediction that we can actually go out and test with an experiment. So it raises this huge question that echoes all the way back to Kepler. Is mathematical beauty enough?
And that leaves us right where we started. The story of Ptolemy and Kepler and Galileo, it's more than just a history lesson. It's a timeless story about how we figure things out. It forces all of us to ask that fundamental question. When a perfect, beautiful idea smacks right into the stubborn, messy facts of reality, which one do you trust? It's a question scientists, and really all of us, are still grappling with.